Okay, so we are having a transformer, and this transformer is basically a device that regulates the current and voltage in a circuit. तो ये हमने डिस्कस किया था कि ट्रांसफार्मर जो है वो लाइक करंट और वोल्टेज को रेगुलेट करता है. इट कैन इंक्रीज और डिक्रीज बोथ ऑफ देम as per the demand of the consumer. So it basically is a device which functions on electromagnetic induction, and it transmits the voltage and current on the behavior of the electromagnetic induction. So whenever we are like transporting or transmitting voltage and current in a transformer, that's only because of electromagnetic induction. The most important thing over here to remember is कि ट्रांसफार्मर हमेशा वोल्टेज और करंट के साथ डील करेगा, और वोल्टेज और करंट एक दूसरे के साथ ऑपोजिटली बिहेव करते हैं. इफ द वोल्टेज इज like increasing, the current would decrease and vice versa. Now there is a formula of P equals to VI जो कि यहाँ पर बहुत oftenly use होता है, and we would be using it oftenly as well, because whenever we have a numerical regarding transformers, in most of the cases transformers के कुछ अपने formulas हैं वो use होते हैं, और साथ में P equals to VI use होता है. Now moving forward, we need to remember one thing, that we have an input side which is called the primary side, and we have an output side which is called the secondary side. इसको हम डिटेल में आगे पढ़ेंगे, बस अभी फिलहाल आपको इतना पता होना चाहिए कि ट्रांसफार्मर जब भी कभी करंट को या वोल्टेज को ट्रांसमिट करता है, दैट इज ओनली बिकॉज ऑफ two different electromagnetic inductions, one on the input side and the other one on the output side. तो जब भी आप मैग्नेटिक फील्ड क्रिएट करते हैं लेफ्ट साइड पर, वहां से राइट साइड पर भी मैग्नेटिक फील्ड क्रिएट हो जाती है. सो दिस इज अ सॉर्ट ऑफ चेन रिएक्शन. आपने इनपुट से वोल्टेज दिया, करंट दिया, उस वोल्टेज और करंट से हमने बना ली है एक मैग्नेटिक फील्ड ऑन द लेफ्ट साइड which leads to a magnetic field on the right side, and the right magnetic field would ultimately lead to the voltage and current on the output side. तो ये एक chain reaction है. The input voltage and current creates magnetic field, which further creates another magnetic field, finally leading to output voltage and current. Now moving forward, we have the types of transformers. So हमारे पास दो type के transformers हैं. We have a step up transformer and a step down transformer. स्टेप अप ट्रांसफार्मर वो होता है जिसके वोल्टेजेस की वैल्यू इंक्रीज होती हुई नजर आएगी आपको थ्रू आउट द प्रोसेस. सो एज वी लाइक इनपुट सम सर्टेन वोल्टेज, आपने आउटपुट साइड पर उसको बढ़ते हुए देखना है. दैट इज अ स्टेप अप ट्रांसफार्मर. और मैंने बताया कि वोल्टेज करंट ऑपोजिटली बिहेव करते हैं. तो अगर आप वोल्टेज को बढ़ा रहे हैं तो करंट क्या हो जाएगा? रिड्यूस हो जाएगा. एंड इन अ स्टेप डाउन ट्रांसफार्मर द एग्जैक्ट ऑपोजिट वुड हैपन. Like if I'm reducing the voltage in a step down transformer, तो आपके करंट की वैल्यू बढ़ जानी है. Now if we talk about their practical examples, तो आपको स्टेप अप ट्रांसफार्मर नजर आता है पावर प्लांट्स के फौरन बाद. ये हम डिस्कस कर चुके हैं करंट इलेक्ट्रिसिटी और प्रैक्टिकल इलेक्ट्रिसिटी में, that whenever we have a transformer of step up type, we use it right after the transmission producer. Like आपका जो भी प्लांट होता है, पावर प्लांट, उसके फौरन बाद आपने स्टेप अप ट्रांसफार्मर लगाना होता है, जबकि स्टेप डाउन ट्रांसफार्मर आप हाउस होल्ड या होम से पहले लगाते हैं. सो दैट इज अ प्रैक्टिकल लाइफ एग्जाम्पल. आपने बहुत लाइक जो आपके पीएमटीज होते हैं या ट्रांसफार्मर्स होते हैं वो देखे होंगे नियर योर हाउस होल्ड और नियर योर स्कूल्स. ऑल ऑफ दोज ट्रांसफार्मर्स आर एक्चुअली द स्टेप डाउन ट्रांसफार्मर्स. वो वोल्टेज को रिड्यूस करते हैं और करंट को इंक्रीज करते हैं. Now step up and step down are having a certain type of bond with the number of turns as well. So in step up we have increasing voltage, तो हमारे number of turns भी increase होते हुए नजर आते हैं, जबकि step down में number of turns reduce हो जाते हैं. इसका सीन क्या है, इसकी डिटेल्स क्या है, वो हमने आगे डिस्कस करनी है. For now you just need to remember one thing, that number of turns are directly proportional to the voltage. Like if I'm increasing the turns, the voltage would increase. If I'm reducing the turns, the voltage would decrease. And the exact opposite would happen with number of turns and current. They are inversely related. Number of turns को आप बढ़ाओगे, करंट ने कम हो जाना है, और अगर नंबर ऑफ टर्न्स को कम किया तो करंट ने बढ़ जाना है. Now moving forward, we have a transformer over here जिसमें आपको एक solid block नजर आ रहा होगा right over here. So it is actually a transformer iron core. तो ये एक आयरन कोर है जो आपको सेंटर में नजर आ रहा है। राइट और लेफ्ट पर आपके पास इनपुट वायर्स और आउटपुट वायर्स हैं। दीज वायर्स आर एम्बेडेड लाइक दिस। तो ये कुछ इस तरीके से कॉइल की फॉर्म में wrapped up होते हैं onto the iron core. Now, if you see हमारे जो number of turns हैं secondary side पर वो काफी ज्यादा हैं compared to the input side. तो आप ये कह सकते हो कि number of turns on primary are lesser and number of turns on secondary are greater. Now, with that being said, we could directly figure out कि एक step up transformer है या step down. As you can see, the number of turns are increasing. प्राइमरी से जब हम सेकेंडरी की तरफ मूव होते हैं तो हमारे नंबर ऑफ टर्न्स बढ़ते हुए नजर आ रहे हैं, विच मीन्स दैट वी आर एक्चुअली इंक्रीजिंग द नंबर ऑफ टर्न्स एंड दैट इज अ स्टेप अप ट्रांसफॉर्मर. और क्योंकि नंबर ऑफ टर्न्स बढ़ गए हैं हमारे तो वोल्टेज भी बढ़ जाएगा. सो प्राइमरी वोल्टेज वुड बी लेसर एंड सेकेंडरी वोल्टेज वुड increase and it would be greater than the primary voltage. Now coming to the current, तो करंट का सीन बिल्कुल ऑपोजिट होना है. अगर आप प्राइमरी साइड पर खड़े होंगे तो क्योंकि वहाँ नंबर ऑफ टर्न्स और वोल्टेज कम है तो आपका करंट इंक्रीज हो जाएगा या इनहेंस हो जाएगा. while if we talk about the current on the secondary side, तो क्योंकि हमारा सेकेंडरी साइड ज्यादा नंबर ऑफ टर्न्स और ज्यादा वोल्टेज के साथ है तो यहाँ पर हमारा करंट कम होते हुए नजर आएगा हमें. So that is the case with number of turns, voltage and current in a step-up transformer. If we talk about a step-down transformer, तो आपका जो केस है वो बिल्कुल ऑपोजिट हो जाएगा and the things would be 180 degree to the step-up transformer. Let's take up an example. We have some turns on the input side and we have some turns on the output side. Now, as you can see, we have the number of turns on secondary which are relatively lesser and over the primary we have more turns. तो आपने अगर देखा number of turns को तो आपको पता चलेगा कि number of turns gradually reduce हो गए over the course of this entire apparatus or this entire transformer. So we are reducing the number of turns, which means that it is a step down transformer. और step down transformer क्या करेगा voltage के साथ? If the voltage is greater, it would make it lesser on the secondary side. And the opposite would happen with the current. Now, for the current, it would increase in a step down transformer like this. Now, we have a couple of formulas for number of turns, current, and voltage. And that is like number of turns on primary side divided by number of turns of secondary is equivalent to the voltage of primary divided by the voltage of secondary. Now, for the current and number of turns, the formula would be completely opposite. Number of turns for primary and secondary are same, but the current would be for secondary in the numerator and for the primary it would be in the denominator. तो ये हमारे पास केस बनता है for the formulas of transformer. These two formulas are very important. ये आपने याद रखने हैं. इन्हीं दो formulas को use करते हुए हम एक third formula भी generate कर सकते हैं, which is number of turns of primary divided by number of turns of secondary is equivalent to the current in secondary divided by the current in primary. Now, I hope this is perfectly clear. अगर इसमें कोई problem, कोई query है तो पूछ लें. Otherwise, we'll move on to the next topic because that was all about transformers. So, is there anything like making any sort of problem to you or something which is ambiguous? जी, कोई query, कोई question, anything to ask? Yes, is there anything to ask in this particular topic of transformer? Okay, perfect. तो अब हम जा रहे हैं अपने नेक्स्ट टॉपिक की तरफ एंड दैट इज अ सर्किट ब्रेकर. सर्किट ब्रेकर के बेनिफिट्स और ड्रॉबैक्स हम पहले कवर कर चुके हैं इन प्रैक्टिकल इलेक्ट्रिसिटी अंडर द डिफरेंसेस ऑफ फ्यूज एंड सर्किट ब्रेकर. तो अब हमने सिर्फ इसकी फंक्शनिंग समझनी है कि ये परफॉर्म कैसे करता है अपने टास्क. सो वी हैव अ सर्किट ब्रेकर ओवर हियर. And this circuit breaker is actually having a pivot, a spring, rocker, and some current. Now, there is a coil around core. If you see, we have a cylindrical core having wire wrapped around it. तो होता कुछ ऐसे है कि अगर आपने ज्यादा करंट सप्लाई कर दिया तो हमारा जो कॉइल है वो कोर को मैग्नेटाइज कर देगा. द कोर, द सिलेंड्रिकल कोर इफ यू सी वुड मैग्नेटाइज, एंड दैट मैग्नेटिक कोर वुड एक्चुअली अट्रैक्ट द पिवट टूवर्ड्स इटसेल्फ. तो वो पिवट को अपनी तरफ खींच लेगा. इफ यू सी जो रॉकर मार्क्ड है, like the position which is marked as rocker would actually attract towards the core and would actually be attracted towards the core, and that would disrupt the entire circuit. तो आपका करंट जो डिलीवर हो रहा था इनटू द रॉकर राइट फ्रॉम हियर would not go into the rocker anymore, और आपका सप्लाई रुक जाएगा. The supply would completely stop because the rocker would come into this particular position with the core. So it would be attracted towards the core, और आपके जो करंट का कनेक्शन था रॉकर के साथ वो अब ब्रेक हो चुका है. Now to resume the power supply, what we do is we actually have a pivot right over here. So if we push this pivot upwards, तो आपका रॉकर जो कि नीचे स्लाइड डाउन कर चुका है वो अब वापस अपनी पोजीशन पर जाएगा, and it would be seen in this position back again. तो अब ये वापस अपनी पोजीशन में आ गया होगा, and it would carry on the current once again throughout the circuit. So that is how the circuit breaker would actually work. Now the question over here is कि क्या ये कोर हमेशा के लिए मैग्नेटाइज हो जाता है या कुछ टाइम बीइंग के लिए होता है. So the answer to this is that this core is of soft iron. So it is soft iron core, and it actually magnetizes for a short duration until certain current only. So it magnetizes for a short duration under certain current only. So if you have a core that cannot magnetize before 3 amperes, तो आप अगर 2.5 या 2.7 इवन 2.9 amperes भी अगर करंट सप्लाई करते हैं टूवर्ड्स द कोर, तो इसने आपके रॉकर को अपनी तरफ अट्रैक्ट नहीं करना है. So the rocker would not be attracted towards the core until 2.9 because the core is labeled at 3 amperes. Once you achieve the 3 ampere current, तो आपका core magnetize हो जाएगा and it would attract the rocker towards itself. So the thing is that as soon as you achieve 3 amperes, the core would magnetize and attract the rocker towards itself, stopping all the current supply. तो आपने जैसे ही करंट सप्लाई को अब रोका है तो आपका जो कोर था वो डीमैग्नेटाइज हो जाएगा फौरन. सो इट मैग्नेटाइजेस फॉर अ शॉर्ट टाइम एंड दैट इज आल्सो ऑन अ सर्टेन करंट ओनली. तो एक सर्टेन करंट के ऊपर ही इसने मैग्नेटाइज होना है. नाउ द गुड थिंग अबाउट सर्किट ब्रेकर इज this one has already been discussed. I'm just giving you a recap of it. So the good thing about like circuit breaker is कि आपका सर्किट ब्रेकर मल्टीपल टाइम्स यूज हो सकता है while your fuse was not usable multiple times, क्योंकि फ्यूज ने बर्न हो जाना है. जबकि आपका जो सर्किट ब्रेकर होता है वो सिर्फ एक कोर को मैग्नेटाइज करता है फॉर अ शॉर्ट ड्यूरेशन और रॉकर को अपनी तरफ पुल कर लेती है वो कोर. as soon as you pull that or like push that rocker back again to its initial position, तो आपका सर्किट ब्रेकर वापस इनिशियल स्टेट में आ जाता है and the circuit starts to work again. So that is a very big benefit of a circuit breaker. So circuit breaker is long lasting, it's effortless, it's harmless, and it is cost efficient as well in the long run. Like if you have a fuse, it would burn off and won't be of any use again. तो आपने अगर एक पर्टिकुलर टाइम स्पैन में 10 फ्यूज यूज करने थे, तो उसी टाइम फ्रेम में आप एक सर्किट ब्रेकर से अपना काम कर सकते हैं. एंड दैट बेसिकली मेक्स द सर्किट ब्रेकर cost efficient in the long run. So that's all about circuit breakers. Now we are moving on to the last topic of electromagnetic induction, and then we'll be done with this chapter. The last topic is relay switch. So basically what happens over here in the relay switch is that you are going to have a glass frame which is vacuum filled, and it won't be having any sort of air or gas present inside. The only thing which is present in this glass chamber is a thin wire or a thin strip of conductive material which could be magnetized as well. Now it's usually preferred to be of iron. We don't use any other material over here preferably. We prefer iron instead. And what we do with this relay switch is that we supply a small amount of current to turn on any large circuit. Like what happens is that I will be having some battery over here, which is going to turn this switch on. Now, as soon as you supply the current, these two strips are going to attract themselves, and it is going to turn on a larger circuit. So they are going to attract, and they would be seen as a single unit after attraction. They would be seen somewhat like this. And after this, what you do is you just connect these relay brackets with the outward circuit. That could be like any appliance. Usually we use these type of switches in heavy machineries. Now, what is happening over here is that we are not using a direct switch to this appliance. इस appliance के लिए मैंने कोई direct switch use नहीं किया है. Instead, what I am doing is I am switching this circuit on, making these relay coils or these relay filaments magnetized. They would be attracted to one another, which completes the outward circuit. तो अब हमारा outer circuit complete हो जाएगा, and that would turn on the larger machinery with an indirect switch. तो ये एक indirect switch होता है which is helpful in turning on larger appliances. Now the question over here should be that why are we using this relay switch instead of a direct switch? Like we don't use a relay switch for a fan or a tube light or an air conditioner, and we don't even use it for larger appliances like our freezers or our TV sets. So why are we using it in machineries? Like heavy machineries are not turned on directly. Why is that so? So the reason for this relay switch being used is that relay switch is actually making it more safer for us to turn on the appliance directly. The thing is कि हमारे पास जो switches होते हैं उनकी कुछ limitations होती हैं. The switches have limited current and voltage bearance. So they won't be able to bear a huge amount of current and voltage passing through them. तो आपने अगर एक बहुत ही हैवी मशीन को रन करना है and you put on some small switch over it, the machine would not turn on. In fact, ज्यादा करंट और ज्यादा वोल्टेज ड्रॉ होने की वजह से आपका स्विच मेल्ट डाउन हो जाएगा and the machine would never work. Although the machine is okay, the circuit is correct as well, but the only problem is with the switch. The switch cannot bear that much load. So what happens over here is that we can either use a relay switch, which is an indirect switch. तो आप एक relay switch use कर सकते हैं, या फिर आप एक heavy duty switch use कर सकते हैं. So the question over here is कि हम heavy switch क्यों use नहीं कर रहे हैं, and why are we preferring the relay switch? So the answer to it is that heavy duty switches are very costly, and if they become faulty, they can lead to fire ignition and explosion as well. Now the thing here is that if we are using a heavy duty switch, the first problem with them is that they are very costly. So if we just burn out a heavy switch in a few months or in a year or so, we would be like making a big dent on our cost because they are very costly. And the next problem is that if they become faulty and we just don't like have any idea of them being faulty, they can ultimately lead to a big problem. Like they could ignite fire. Like if you would have definitely seen that we are having cases of fire or like explosions being taking place in some industries or factories. That is because of heavy duty switches not functioning properly. So that is a major problem. And this could be resolved only by a single thing, and that is a relay switch. A relay switch is so very cheap that in a cost of heavy duty switch, we can bring out or we can create hundreds of relay switches. And the relay switch, since it's not working through a heavy amount of current or voltage, it just only needs a battery or a small cell to function. So it would be very long lasting as well as being very cheap. So it's safe, it's cheap, and it's long lasting as well. So all of these things add up to the chances of using relay switch over any heavy duty or regular switch. So that was all about the relay switch, and in fact that's all about the entire chapter of electromagnetic induction. तो यहाँ पर हमारा मैग्नेटिज्म और इलेक्ट्रिसिटी का सेक्शन हो गया है कंप्लीट. We are now going to start with radioactivity in our next class of Friday inshallah. तो आज के लिए फिर इतना ही रखेंगे. I just need a confirmation from you if you are perfectly clear or if you are having any sort of query. तो इसमें आप लोगों को कोई like problem या कोई query, anything you wish to ask, or are you like perfectly clear? Yes, anything to ask, or is it perfectly clear? Yes, definitely. We do have space physics in our new syllabus. The thing is that we are going to complete radioactivity after this chapter. तो hopefully 2 classes या at max 3 classes में radioactivity हो जाएगा complete. उसके बाद हमने शुरू करने हैं कुछ different chapters. If you are from IGCSE तो momentum पहले से आपके syllabus में था, जबकि O levels के जो student हैं उनके syllabus में अभी induct हुआ है momentum. तो हमने momentum भी cover करना है after radioactivity, and we are going to cover the section of space physics as well. So probably the same goes with physics, just like maths. हमने physics का syllabus भी इंशाल्लाह end of March तक cover कर लेना है. So we would be moving on to the revision in April. So that is the timeline and the planning so far. So let's see how it goes. So that's a wrap for today. See you then inshallah on Friday. Take care. Allah Hafiz.